Okay, this is the second video to accompany the worksheet, again, also posted on Schoology for coordinate geometry. So I'll go through and do a couple of examples and then make sure that you guys do the you try section. All right, so I want to figure out the distance between two things. Well, there is technically a distance formula, but basically it's just a variation on the Pythagorean theorem. That's ultimately it. So I'm going to go ahead and just use the coordinate plane for this and then create a right triangle so I actually can do the Pythagorean theorem. So I'm going to go ahead and take my points. I'm going to plot them on the graph. So I have negative 3, 4. So there's 1, 2, 3, 1, 2, 3, 4. I'm going to plot that point, and I'm going to call that point A. All right, I'm going to do the same thing with B. So I've got positive 2, negative 2, and that's going to be point B. And what I want to do here is I actually want to draw the line segment between the two. Now, since that line segment is not going either vertically or horizontally on the graph itself, then we're going to have to, can't just count the boxes, because we don't know how many full boxes it is if we're only kind of going sideways through boxes. So what we're going to do is we're going to use the idea of creating a right triangle, so actually drawing line segments that go vertically and horizontally. So we're going to use the boxes to help us. So if I start at point A and I want to go down until I'm level with point B, additionally, I'm going to do the same thing for X. I'm going to start at the end of that box and go straight across. Now notice I was able to create a right angle. This is spectacular. Because I get to do that, now I can actually just use the boxes. So let's go ahead and count the blue. So it looks like I have 1, 2, 3, 4, 5, 6 boxes here. So I'm going to put a 6 here. Now it doesn't matter if I'm counting up or counting down. We're not talking about slope, we're just talking about how far those two things are away from each other. Okay, then if we go back to the orange, count those boxes. We've got 1, 2, 3, 4, 5. All right, so let's put a 5 here. What I'd like to do is I'd like to find the length of the black line segment. Well, since the black line segment is directly across from the box here, I know that in Pythagorean theorem, that's going to be identified as C. So I'm going to go ahead and take my 6 and my 5 as the legs, and I'm going to plug it into the Pythagorean theorem. So I'm going to have 6 squared, and then I'll have plus, so that's my X. Oh, excuse me, that's my Y. And then I'll do my X, which was 5 squared. And then I'm going to do equals the hypotenuse squared. So now at this point, I would go through and either grab my calculator or I would go ahead and do the math myself, because you guys know I'm a big fan of exact answers. So if I did 6 squared, I know that that gives me 36. If I did 5 squared, that's 25. If I go ahead and add these guys together, 36 plus 25 is 61. Now I'm not done. That length isn't 61 units long. That's way, way, way too long. I need to get rid of the squared. So I'm going to square root both sides to get the square and the square root to cancel. So I can get C by itself. And it looks like C is equal to the square root of 61. Now, if you type this into the calculator, I believe it's going to be 7 point something. So it's just a little bit under 8. That is the length, or the distance between point A and point B. Okay, and we can go through and do the same thing here. Now, since I'm running through this video with you guys, now would be a great time to pause the video and then see if you got the same answer that I did. Okay, so at this point you've probably picked up, and let me catch up with you. So I would plot my point, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So I've got my point A up here, and then I would plot my other point, which is -1. And then I already have 1 right there up. So that's my point B. And then additionally, I would go through, connect those two dots. Notice that it's not vertical, so I can't just count the boxes. All right, now you can go ahead and draw in the length and the height of this triangle. So use the fact that I can, excuse me, that I can count like vertically and horizontally, which is actually kind of nice. All right, so there's my that, and then let's move this across. Notice that I was able to make a right triangle. And then it doesn't really matter if I went up or down. That's not what this is about. I'm just trying to figure out how far the two things are apart from each other. So I have 1, 2, 3, 4, 5 here. And then across the bottom, I have 1, 2, 3, 4, 5, 6. Oh, that's interesting. So I have a triangle with the exact same dimensions. Notice that if you look at the previous problem, I still have 5 and 6 as the legs on this. So what I would do is I would go ahead and set up the information that I have here. So I know I have got 5 squared plus 6 squared. Again, their legs. Go back to the picture. Notice that I am across from the box, so I'm trying to find C. Now, I don't have to go through and do the exact same calculations all over again. I do want you guys to realize that what I have here is a similarity between the two setups. They're identical. So the information that I did there is the exact same information that I did there. So there's no point in redoing the work. So since I've already got my work on that page, now, if it was work that you did somewhere else or on another question, it has nothing to do with what we're doing right now, then yeah, of course you need to set it up again. However, these are on the exact same page. So I'm just going to go straight to the punch on this. I know that this is going to be the square root of 61 because my work is already shown.